Okay, before the break, we looked at shape key animations. Those are very, very useful. I think my list for today was a bit long. So I still wanted to do movement and water shader, but I wanted to make sure there was like close to 2 hours of practice time today because we've seen a lot of stuff, and that's really how we learn, clicking around. Like, I'm expecting you to have to do those shape keys 4 or 5 times, maybe more, and try different things. Make a box with a triangle on top and call it a house, and then add a door and do a shape key for a door. That's a very common one. Make a little canoe looking thing and have an oar as part of it and have the oars rowing. Try to little shapes where it's just small movements. And really get familiar with where the tool is now. And then as you progress and get more practice, then you'll know what to do with them when you're ready to start working on your big, massive projects, right? Or final drafts, right? Early drafts are good. We just need something as a placeholder until we're finished writing the code. But when you're ready for further down the road, when you're ready for final drafts on your games, then you'll be a lot more familiar with shape keys. Just introducing things. So it's the next thing I wanted to look at movement and another shader. I think I'll do another shader because I'm gonna do some animations, skeletal animations, which probably be on a character on Monday. So that might be another good time to address the movement. And we've got those default movements for now. So I also had a shader in mind for some water here. Should have opened up an example. Once again, I started opening it up and I got like halfway to the folder on Drive, and then kind of got distracted and did other stuff. Triathlon, that one has water in it. And I'm not looking at this exact prepared ahead of time. I'm looking at examples from different things. I was looking at the sky when, well, it was very similar to this. I was looking at the one from the summer camp that we did that we ran last year, where we did use the Blender landscape button and tree sapling and the multi-mesh instance to turn it into a forest. So that one was very similar. It's not the same game. So remember, keep those little pieces in mind. As you build more and more games and keep examples, you don't have to look for a game that's doing the exact same thing as you do. I saw a couple questions on the Godot 2D one about the save logs. There's some problems in that, and people were looking around for things, but lots of games have save logs, right? We don't have to find a 2D platformer save log example to follow along. For something like a save log, that's a text file in the background, which for some reason that video called it binary file and then wrote JSON code to it. You should really put the .json extension on it. Then it's JSON data, and just about every software that exists in 2023 knows how to read JSON data because that's standard. Your browsers will automatically format JSON data for nice and pretty print, but not if you give it the .bin extension. I'm not sure why you did that in the tutorial. JSON isn't very, very standard. So the normal file extension for JSON is .json. But we can look at any type of game that has a save button and see how they write the file. We just need that little piece, not the full game. So as you build more and more games, keep that in mind that you might go back to some of your previous examples, which you will want to save for reference material. It's a lot easier to reference your own stuff because then when you see that code, it helps to remember what you were doing when you learned it, right? It was 2 or 3 years ago. You could go look up the same tutorial you learned it from, but if you go back to your own code and see what you wrote and how you used it, it'll help you remember all the stuff you were doing at that time. Your own code is better reference material. Just keep track of the small pieces. Water shader, that's the example I want. So, this doesn't look much like a river right now, right? There's no color at all on that river. I selected the wrong thing. River. So this plane right here, it's just a plane. The only reason it has any blue at all is because it's reflecting the sky light. I forgot to look for that checkbox. There's a checkbox to make it so that the skylight doesn't affect everything, and I forgot to look at for it the other day. Let's see if we can find it real quick. Light enabled editor. Zoom button turned away. Yep, I do not remember where that checkbox is. It's under world environment somewhere. Sky is. Go to world environment. Ambient light is part of that. Source, background. If we disable it, then we don't get that sky color on our world. No, I don't want to select that. Let me.
At least for me, I really don't have see any tinging.
So I went to ambient light and disabled it. So ambient light would be the reflected light that's around. That's one of the places. There's another checkbox somewhere, but I can't remember what the other checkbox is. And also, I'm going to go to the collision shape here and turn off visibility on that. There we go. We don't need to see those blue lines everywhere. Those are just, those kind of clutter everything up pretty bad. Then we get a better picture of what it's going to look like. Or in realistic situations, the reason that's there is we would probably want the sky color as the background. What is it two of them? Background. I don't see a difference in those, but I guess sometimes there would be. Realistically, the color of the sky is going to affect everything around it. Y'all have probably noticed that at like sunsets and stuff, right? When the sky gets really colorful, our t-shirts change tint a little. So if your game doesn't do that, it would look unrealistic. But if you do it too much, then like if you found the perfect color ahead of time and then your sky affects that, then it's not going to be the colors you chose for your game. So here on the water, we need some color here. So I'm going to choose this, and there's our mesh. We created this mesh and a bunch of options on it. Can minimize that one. And right down here is the surface material overrides. This is where we create a material. So if we expand surface material overrides, see there's no material. We could do a new standard material.
All the submenus.
Or again. ORM material. What's that?
Time to dive into all the submenus again.
Not as many this time. But yes, not as many. But we could do a standard material, which are the ones we've been seeing. That's the base color, the roughness, metallic, specular. I guess standard material has albedo. ORM has different options, but sort of the same thing. Two different rendering pipelines we could choose materials for. Or we could go to a shader and actually write the code for our stuff. And if you're in this class, you probably want to learn about coding shaders, which like we saw the other day and I pointed out, we use keywords that are already built into OpenGL for us. So a lot of that is spending time with the documents, looking at what functions are there and figuring out how you can put it together. And getting practice with it. So now shader, no material yet, but if you click on that, digging into the new things, you'll see the preview. It's previewing an empty shader, so we need to click here and create a new shader, or if we have one loaded, right? Like I'm referring to an example on my Google Drive, and instead of OneDrive, I have Google Drive connected to all my machines, which is kind of nice instead of Google Drive or the iCloud. OneDrive that only works on the Windows machine, or iCloud that only works on the Mac. I should use Google Drive on all of them. Linux and the Chromebook and all my machines can access the same storage. So I could just load this shader in, but obviously for the purposes of class, we want to make a new one. We're making a shader, and didn't really point at this box, but last time we chose to make a sky shader, but notice there's, for those who have seen a little bit of object-oriented and gotten into inheritance, this is what shader object are we inheriting from? The general one is spatial. We're usually going to have a spatial shader, but there are some consistent ones like sky shaders or fog shaders where a bunch of things are pre-set up that we might want to use. Particles have to do with physics, so that's one way that's the traditional way to make rain, but there's improved ways. Somebody come up with a more efficient way about 3-4 years ago, and that made it around tutorials and showed up in just about in YouTube tutorials for all of our game engines. But traditionally, rain would have been done with particle shaders. Now it's done with actual particle physics. We actually make a model of a raindrop and then apply physics and something very similar to that multi-mesh instance. And there's actually something which is a little bit nicer because then there's some raindrops fall and bounce off our characters, hit an umbrella and roll off the side. Maybe somebody figured it out a long time ago, but computers were finally able to handle that.
Basically, instead of just
NVIDIA finally made something big enough, I guess.
Instead of having an animation of raindrops flying past your face, there's actual objects.
Yeah, there's an actual raindrop object dropping and hitting and bouncing and splashing, and with liquid physics applied, so sometimes the raindrops they can blend together and come apart and all of that stuff. But at other times, if an animation of raindrops falling past the faces enough, then the particle shader would be more efficient than all of that, obviously. We just want a spatial shader, so create a new spatial shader. The template is either default or empty. Default gives us the method we need for it. You probably always want to leave it on the default. Basically, the template option is there for when you're ready to build your own templates. That's why they included it. Unreal and Unity do the same thing. There's a template option, and when you click on it, there's no options there. That's so you can make your own templates.
And so when you have a thing from some other project that you want to toss in here and reuse, you can do that.
Oh, that's what the load button would be for.
Oh.
So there is a load, because it's just saving a text file. So we could just load in something from another project. A starting point, if you want to use the same starting point over and over again. I'll call this water.
Did you put in it?
Oh, I just called it water. Down at the bottom, it has res:// so that's your resource folder. Resources, and then somewhere in there, I just gave it the name river or water or something, or put a folder name in there to organize things nicely, because this one's kind of a little disorganized. We should not have all of our assets at the top level like that. That's going to become that's already a very long list, and we haven't really done anything with our game except looked at a couple of tools for making games. And it's already long enough we have to scroll. So we have that water shader. So we go down at the bottom, switch to our shader animation, and then try to find a spot in the viewport where we'll see it nicely. I think we'll be able to see some water there. And the thing about shaders is shaders aren't going to make ripples on the surface of that plane. Shaders are going to cause the way the light reflects off of it. Like that shadow there is a good example. That shadow is just something in the background, how the light is reflecting off of it. Shaders just make the light reflect off of it differently. So it'll, instead of right now, the light all reflects straight off because it's just a flat plane. So we're just going to split that up and tell the light to reflect in all sorts of different directions and dynamic directions. So what do we need? We need a color for that, obviously. Saw this before. So our keyword uniform is going to put it over in our inspector panel. A color is a vector. three numbers that go together. We can't separate the red, green, and blue and have any information about the original color. We need all three parts. So I'll call it watercolor. And a colon to say that is going to be a source color sort of selector. End of instruction. And now if we hit save, we should see the shader parameters show up over here. And in the inspector, we can expand that new one and choose a good color for our water. It's always a nice starting point, right? Which we don't see it yet, but just like we saw before, that if we come down here, notice we have this method. This time there's a method called a function called fragment. In the sky type, it was called sky. Yeah, the names that were picked decades ago. So in fragment, well, we've seen this word before. Whoever made the color, the sky shader decided to use color. Usually, albedo is the color. Albedo is the root color. Y'all probably heard that word in at least two situations. If you heard that word, it related to cameras. Albedo on a camera, photography albedo. That's the color value. That's the color data going in. So albedo means color. I guess if you just remember that. And to start, we'll just set it to that watercolor we just set up. Choose it from the list and end of instruction. When you're over here in OpenGL, it's from C family of language. So remember to do your end of instruction character every time. That works. We have all these options. I'm going to say something I like to do is I'll leave the blender plane in there a little bit lower, and then I'll use what I usually do, leave the plane from blender a little bit lower. Then I'll bring a new plane in from the engine and set that above it. And the watercolor, I will make that semi-transparent. So then we can see in the water. So like when our character goes in the water, we can see it. But if we were to make this sort of transparent, where's my alpha value? RG. I gave it a vector 3. I have to make it a vector 4 where we have transparency. Then we would be able to.
Can we do that?
Yeah, I think it's just vector 4.
Because I mean, there is a riverbed down there. We didn't delete it. We just deleted the water.
Oh, it doesn't like vector 4. To do this, can also just put the alpha here. The value alpha is the same as if we had the 4-dimensional color here. Alpha equals like 0.75. Instruction, and that'll give us that color somewhat transparent. I guess we can see it there with those where mine has randomly generated trees. See how we can see that it's a little bit more realistic. And I like to leave the other plane in there so there's a lower limit to how far the character can go down. A lot of times I try not to put it below head level, and that way it switches to the swimming animation, but the character is actually walking on the ground on a solid surface that the player can't see, but it's doing the swimming animation and the collision shape is still touching the ground.
Basically,
that other plane.
Movie reaction there.
Yeah. So yeah, remember a lot of times we just have to do things that give the illusion of what we want. And I found that having a secondary plane underneath there that isn't really colored for the water works really good. Or make it dark, and then the transparency only goes so far in water, right? 3 foot deep of water, we can see the bottom. 12 feet deep of water, we can't really see the bottom anymore.
Depends on how clear it is.
Yeah, that's true. Dale Hollow Lake, if anybody's been down there for vacation, you can definitely see the bottom in like 60 feet of water. But that is a rare thing, and that's why that's such a awesome vacation spot. because it's very rare for that to happen. Usually only a few feet deep. Silver Creek right out here, 3 inches, and we're not going to see the bottom
I
anymore.
was gonna say, a lot of the water sources around here are very bad for examples of clearness of water.
Silver Creek's exceptionally bad because it starts up on top of the knobs, and the first thing it does is go straight down a really, really big hill and picks up a lot of mud, and then it flows through a bunch of cities, so it just gets dirtier as it goes. But that's one that would naturally be muddy the whole way through, like the Yellow River in China, just a smaller version of it. Okay, sorry, without getting distracted. So now that gives us our color, and just being transparent looks a little bit better. Sometimes we have still water, but probably want to add some texture to that, like we saw. Oh, you know what else we could add in here? Since got distracted and add the alpha, we also add in metallic. Whoops. Get back to the predictive text. Metallic. Because this is our material, right? The albedo, or the base coloring, the RGB values that we mix. Alpha is opaqueness. So 100% alpha is fully opaque, 0% is fully transparent. Metallic, roughness, specular density, that's the stuff we have to work in our code with here. Water is probably going to be somewhat metallic. We don't think of it as metallic like
Reflective.
Yeah, it's going to be metallic and specular because it's highly reflective, but it's a solid surface. Right? It's not rough. Water is smooth. It's liquid. So no matter what we do, water is going to smooth out. And just like alpha, we're looking for a percentage. So something between 0 and 1. A percentage in the calculator formula. So 0.87%. Right. Everybody's familiar with that, right? Percentage is just easy to say. Numbers like 0.87 do not fit into sentences nicely. Then we could do specular intensity. Specular. I'll just do specular. 0.99. They get very reflective. Now we're and all whatever values you think would make it look a little bit more like water. Water's going to be very completely smooth. I guess we can set roughness. Might as well while we're here, right? Set our roughness to 0. The only time water would ever actually be rough is if it froze in a bumpy format. No matter what, it's going to smooth itself out as much as possible. But that's the other thing, some sort of replicas. Even without moving anything, that water is looking a lot better, right? We can see those trees in there. The shadow, that's the specular thing right there, what that shadow's doing. Is it coming through on the TVs? It doesn't seem to be coming through on the TVs very well. I turn up brightness. No, my brightness is all the way up. On my screen, it's looking really good here. There's shadow on the surface and underneath. I don't think it's showing up on the TVs in here, but maybe it's broadcasting.
I can kind of see it on the TV.
But yeah, that's coming from the specular.
But only because I looked on Zoom first.
Okay. Maybe it's showing up better on your computers, but yeah, those things that we have, albedo, which often includes alpha, but here it's probably easiest to keep alpha separate because we can also access all these values from our other script as well.
I was gonna say, couldn't you do
Metallic, specular, and roughness. All materials are built of those.
well, I was gonna say, couldn't you use uniform and pop those out?
Yes. So if you wanted to adjust it, let's do one for metallic just for reference purposes. Uniform, float. This is floating point number. Let's call it water metallic. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100%. 100% And here, I want it to be a hint range. Oh, the default works there. It goes from 0 to 0.1. Put in our end of instruction. So our hint range is 0 to 0.1, and we want a default value of something. What do we set that metallic at? 0.87. So we'll say our default value is 0.87. And now see how that gave us the little slider. So if I come down here and put that variable in here, water metallic, get that a save. When we drag that slider, oh, there we go. We can see that metallic property change on it. If I type 2.3, notice it drops back to 0.9. Like I can't use 2.3.
Is it because we put 0.87 there? Is mine's just going from 0.9 to 0?
Oh, maybe I did the values wrong. Maybe it's
That was like 0.1 there.
is it maybe this is the default. And then go from there we go, from 0 to 1.0. Oh,
Can't you do the thing like click on hit range and see what the
I was hoping so, but it's not popping anything up. I thought it was min, max, and then default. But it looks like it wants default maximum if I put a 0 here. Three numbers, and they do not come in the way I was thinking of. Oh, actually, we don't need three numbers, do we? This is to go back to 0 to 1. There's a 2-number option. This is overloaded. Let's do the 2-number option. So if we just put 2 numbers in, then we have our minimum and maximum. And we can just choose a value over here. So if we move it to 0.743 or something, and we can adjust the values there. That one was mostly for minimum value. So there's 2 and 3 numbers, and I can't remember which one's the default value. I thought it was min max range or min max default, but that's apparently not what it was. Have to look it up. But if we do 2 numbers, then it's the minimum and maximum, and you can just adjust it in the inspector. That's probably the one you want to go with. Now for our surface, we can do what we did the other day, right? Let's make a uniform, a sampler 2D. What are some words that would go with ripples? Crest and trough, maybe. Oh, one over crest. But this time, unlike the other day for the clouds, I want to make 2 of these. Oops. Another sampler 2D. Oh. I spelled uniform correctly. And my computer is starting to get really slow. It's not just the Zoom call anymore. If y'all are wondering about that, it is starting to get slow. Maybe if I close Blender, that would help.
My laptop has been trying to take off for the last while. Its fans are about to.
Yes. Shaders do take more processing because the computer has to do all these calculations to figure out what it is. With a pre-built material, it already be in there. Crest and wave. something like that. The two parts of a ripple, right? Say they're not like waves where it goes up and down smoothly. There's all different levels of bumps. At least that's what I was thinking. No, wait, I don't want to call that wave. Yeah, I'll call it crest and trough. It's not really trough like a wave, but since I use that word,
You're kind of like on the bottom, right? Basically, of the wave.
yeah, that's one way to think of it. Actually, there would be another. So, yeah, a wave goes up and down. So, like this would be the default level. A ripple goes up and then maybe up a little less and up a little more, but it goes up but not down. So I was looking for ripples in the water, but that's a small technicality. If we made this, it would probably look, it would still look correctly if we did small waves. But I didn't want to call it wave because now we need a directional wave for it to move it. Uniform. Oh, actually, an example was calling it wave, but I had thought of a better name. But a vec2, because we just need a direction on this flat surface. Maybe words like ebb and flow. Call one of them ebb. That's going to be a new vec2. That goes in some large direction, 2.0, 0.1. Uniform. Another vec2 called flow. Those words seem to go together. So the way the ripples ebb and flow across the water. This will be another vec2, and this one's going to go in a very different direction. So 0.2 to something much smaller than our initial number. Maybe I'll make this 3, and this is like 1.5. So think of those as legs on the right triangle, and what we actually get out of them is the hypotenuse of the right triangle. That whole arrow in space thing. Those two arrows in space, you want them crisscrossing. Okay. Another thing, when waves collide into each other, this is the big difference. What I was looking for, when waves collide into each other, they add and subtract from each other. Because a wave is actually the energy, and the water is just moving along with that energy. A ripple is a movement in the water. So when ripples collide into each other, they like bounce off each other. If that makes sense. Think about what you've seen in your life and throwing a rock into the water versus waves actually stirred up from at the ocean or something. If you have personal experience, you can draw from there. Then time scale, small number, probably be good. Now we can do what we did the other day. So we need our two movements of the ripples. So I'll create a vec2. I'll call one of them rip and the other one full. I'll just split the word in half because I want two of them. And I'm having trouble coming up with words to use for all these. And that's just like we saw the other day. That's going to be the built-in time value times our two directions that we set up. So the ebb, and then we need some really small number, 0.025, something like that. Vec2, and now I'll make the other part of the ripple, which again is our time value times that other direction that we put in there, the arrow that it's pointing, multiplied by, I'll just do the same small number. Obviously, afterwards, when you're getting practice and stuff, play around with those numbers, try doing different numbers and seeing how they mix and match, changing those values around slightly. So maybe put something like that, use the uniform keyword up at the top to put it in the inspector so that you can change the slider while the game's running and see what it's doing. But we do see a preview for it. Not yet, but we're getting ready to see a big preview for it. Because now we can use a texture for it. We can make some textures. Or just mix it all at once. I'll do it on a couple levels. So let's make a vector 3 called or color 1. Because really all this is doing is changing how the light's reflecting. So it's changing the color of it. So we're doing all that stuff to change the color of it. So we'll have color 1, and that's going to be a texture that's built from our first normal map, which we haven't selected yet. Those normal maps, we call them crest and trough up there. Crest, and then we can take UV plus that time value we set up, that rip. And we just want the RGB value from that. So after we do the texture function, then RGB. And UV here stands for the next letters we use after X and Y. So if we take texture refers to a picture, that's a word that often refers to like when we have a sprites. Our sprites are one texture. We have that picture, and it lays flat as and since it's a picture on a flat plane, we have X and Y coordinates, right? But we already used X and Y coordinates in our game, and we don't want to get them confused because we're going to refer to the ones unique to that picture. At the same time, we're referring to the ones for the world in our game. So U and V are just the next best option to use after X and Y. So that's the XY coordinates of the picture we just created. Or whenever we choose our normal texture. Same thing for our other color. We need a vec3 for the color 2 that we're going to create from this shader, which will be a texture. With trough and then UV plus the other half of the ripple, the PLE, I guess. And then we'll just pull the RGB value from that. Lots of different things in textures we can pull out, like we could pull height maps from, and then actually change the surface of our water. But that would take a lot more processing. So just a light effect would work. We just need the coloring effect. And now we can mix this. So effect 3, I'll call it splash. That's a word that fits with ripples. So the splash of our water is going to be a mix of color number 1, color number 2, and some value. I'll start with 0.7, which again would be 70% color number 2, which leaves 30% for color number 1. And now we can make that then we'll use that as a normal map. So the other day we just took a normal map and put the normal map as part of our coloring. Now I want to take, instead of the clouds, I want to just do a normal map here. So we'll have the color and normal. Whoops, I spelled it correctly. Normal underscore map. And what normal means, normal is the direction straight out. So from the board here, there is some angle that is straight out from that board. From the computer monitor in front of you, there is some angle that is perfectly straight out from that. So what we are doing is we're using that way, those little bumps changing with time, those two little arrows we set up that change with time. We set those up so that it constantly changes what the straight out direction is, which means the light is going to reflect differently and give the illusion of ripples in the water. then we'll use the splash that we just created as the normal map. Uh-oh.
That changed it.
Mine all went away.
It's there. It's just very, 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 very clear now. You can see the line still. If you look at the right at your bank, you can still very vaguely see the line of different
Oh,
heights.
so it's really clear.
Yeah,
Very clean.
mine is crystal clear.
Too clear.
I'm trying to get all this.
It's dark.
So then it's
I think his light of his world's different.
Okay, this is not what I was expecting to happen.
Your world's definitely darker than mine, but I can clearly see mine. It's very, very clear now.
I'm gonna take this alpha value out, so I'm going back to the non-transparent one. I'm just gonna move that to the bottom. And we do get different effects depending on the order that we do these things in as well. Where's my son? Is my world really dim?
It's dimmed very much. At least what I'm seeing on TV.
Uh,
I have my sun very close to being straight down.
Where did I skip here? Let me look at my example. Did I skip a line?
Doesn't matter if I have it at the top of the
Oh,
box.
I'm missing things from my example. So we've got watercolor. Roughness. Oh, wait. Sorry. I have to give it a part. We haven't loaded in a noise sample yet. So right now it's loading in the noise. Null is the noise sample. That's why it's transparency. It's trying to do all those things with emptiness. I apologize for that. I probably should have done that earlier. When I was looking there, I moved it to the bottom. We do get different effects depending on the order we do these in, because the normal map applied to already having the metallic there versus the metallic applied to the normal map is going to be different. So shaders get very, very precise. But if I come back to that water, shade of material, shade of parameters, our crest and trough, the two parts of the middle are still empty. But again, we can choose a new noise texture.
New noise texture 2D.
Yes. Oh, is it 2D?
That's what it looks like. I don't see a 3D option.
Yes, yes, new noise texture 2D. We'll come back to those parameters. And then down under noise, right click on that and the new fast noise. And when we click on that, then we can choose our noise. So right now it's simplex. You can kind of see what simplex is there. It smooths out the noise are various ways we have to smooth out random things. Cellular here is a very fancy adjustment on Voronoi. Voronoi or Musgrave is the common way. I talked about Perlin the other day. Let me talk about noise. Real quick. So two of our most common types of noise versus random numbers. Berlin was actually made for the effects in the special effects in the original Tron movie.
I think somebody spoke to me.
So random numbers are going to be scattered all over the place. So we take several samples. Usually the lap all the way around. So our first one's smooth, and then maybe like 2 in here. So that looks like it's down from there and then back up. And then I'll just do a quick one. Split those up again. Then for here, looks like it goes up to there. This next one's way down. This one is still pretty far down. And then we're back to our starting position. And when we take these numbers and average them, we get something that's a lot smoother than our original bump. So this one would be, it would go, we have an up, way up, little down, and flat. So it's just going to go up a little. Then we go way down, a little down, then flat. So it's going to go down a little. Then a couple steps back up, and we end up with a nice smooth transition. That's per Lin noise. So averaging samples. Voronoi, we split things up into a grid. I'll just do like 4 spots here. That'll work. And then we choose one random point in each one of our grids. And then we come back and find the closest spot to each one of those points. So like here, it's way up here. But then a lot of the parts over in the second grid are going to be closer to this one. So we get some line that's like that. And then this one, something like that, and all those points. And we would do a grayscale on how close it is, so that when it's right next to that point, it's either white or black. I'll go with white. And then the furthest in that circle away from that point will be black. And it kind of breaks up our thing into something that looks like a cellular structure, a very natural looking cellular structure. See how it's making the grid uneven, but it's still a grid. So think of it looks more like organic cells, biological cells. The grid's just shuffled around organically. Those are 2 of our main types. We also have Musgrave, Voronoi, and Musgrave is just like Voronoi. Voronoi is the closest of the Musgrave. So we could also do the second closest or third closest, or we could split it up into a grid and mark all the points, the 5th closest dot. So Musgrave, we choose some value of which one of those random points we want to mark as closest to. Voronoi is the closest because that one goes nicely with pictures. It'd be really hard to think about what the 5th closest spot to each one of those dots is. Computer doesn't have any trouble with it though, so it's super, super quick and it's fairly easy to write the code for them and stuff. It's actually a lot of fun to write noise textures because we have random numbers. Random numbers are easy. We can get those in every language. But random numbers are random and very, very unnatural. We need to smooth that out. Or when we have a grid, again, it's very, very unnatural. We need to make it seem more organic, more real.
I have to say I added the noise texture to my water, and now it looks like somebody spilled plutonium in my river, or it's now some sort of particle. The changing river.
Okay, so notice as soon as I added the second noise texture in, I see blue again. Not on the TVs in the classroom, but on my screen in front of me, I can see blue. As soon as I added the 2 noise textures, whoops. As soon as the second one was in there.
Is it not as dark as your laptop?
It is brighter and it's different contrasting than things. The green's a different green. So if I choose what the second noise is going to be, if you want to look at it.
Let's do it.
It's quite a bit brighter.
Yeah.
Now it's showing up on the TV.
Okay, yes, it helped to get that stuff out of the way. Let me zoom out. There we go. See how we're getting a little bit of ripples now? And if we choose those, we can do different ones. I choose this and look at all the different options. Expand the fast noise. So cellular is an exaggerated Voronoi. It could be an exaggerated Musgrave. I found this exaggerated Voronoi. Cubic values are another random thing. You'll want to look through some of these that might make a good looking water. And they do not have to be the same one. So like a simplex smooth, a smooth simplex and a Perlin might mix together very nicely. And adjust the parameters. This Perlin. And see how it's very, very large, massive. Probably should have chosen some smaller numbers on those, on the ones in the shader. That's where I thought, if you remember, I started to do a 2 and then stretch it out. So maybe I go with smaller numbers. Like that at 2, and then this one like a 0.5. You need some extreme shadows. We're starting to see the like ripples and things might be good to change here. I wanted to wrap it up 325 and it's there right now. We can change the speed of it, the frequency. Yeah, make that per liter. And noise. I turned the frequency up on one of the noise textures. Right below. So when you go down and expand the fast noise option, right below the where you actually choose the noise type, you'll see speed and frequency. I'm getting all kinds of like dark white things, way darker than I was expecting.
I don't see a speed thing, but
1 second, I'll be right back here. I'll take my sun and turn it down at a steeper angle.
oh, found it.
Found it? Okay. So I'm gonna come up here. I'm getting a lot of black there, which I think I can't help but wonder if that's just from the indirect light. The sun comes down first to like midday, and I'll select the river F so that it sort of zooms in on the whole thing. And
You're zooming too far in.
yes, okay, there we go. That looks a little more watery, less black. So, so that speed thing. Sorry. So here's the noise and the shader parameter. We click on that. We see that option, and down at the bottom is the actual noise we chose. When you click on that one, then right below that selection is the frequency of how much that shows up. Different speeds to it. Try different things. Fractal can also help. If you switch fractal to grid, that probably look good for water. I'll do that on both of them. Here I have raise frequency and I'll switch to fractal. That's looking a little bit better. I'm still getting some really dark spots in mine, but could play around with that. But we were just introducing the concept of it.
I don't think it was dark spots, it might be clear spots, at least if it's like.
Okay. What comes, let me put the alpha back in here. Okay. Is 0.8.
Yeah. Also, a little bit.
Okay, that kind of helped. They were still blue, but they were darker than I was expecting. Yeah, it's missing a lot on those. It looks better on my screen. I'm hoping, I know some of y'all are gamers, so you probably have better looking screens. So it's probably hopefully coming through better on the Zoom call, but the Zoom call drops things. We'll get that water moving. Our time scale seems kind of quick there, doesn't it? That's a serious river, so we might move like that. We'd probably want to make sure that's flowing straight down the river so it looks like a current. The ripples going across would be much slower. Add another 0 in there. And slow it down, slow it way down. So now it's just like ripples waving on the water. Trying to find a good angle for it up here.
Oh, that looks a lot better. That drastically cut down. I'll show you what mine looked like here before. It looked like an energy shield.
Too much transparency. The transparency is pretty sensitive. Once you pass 50% transparency, you might as well consider that just a touch. So 50% transparency is a lot. But yeah, little subtleties you can try changing different things. Maybe if I take the metallic down, instead of specular down, let's make specular down around 60%. See what this does.
This is an example of tweak it till you get it where you want it.
Yeah.
It might take you a long time to do it.
Yeah, now just little tweaks. Because every single one you do is going to be a little bit different too. Right? Next time you put water in, you're going to do different tweaks than what you did in this one. Depending on the lighting, the props going around it, all of that different stuff. I'm just going to type in a number here. 0.3. I don't know how well it's coming across the Zoom. It's probably looking different, but yeah, let me not do that. That looked way better the first time. That made it super bright. But that looks a decent starting point. Now it's a matter of tweaking that shader till we get it just right, which is why it's also nice to have it over in the inspector, because then we can slide things and move values and reset our default and all of that. But does the idea of the shader make sense there? Okay, I wasn't seeing the white spots. I was looking for those earlier. Now that I see the dark and the bright spots, mixing them with that blue, it makes a nice looking water pretty quick. Now it's just tweaking values. Does anybody have any questions about the shader? Stuff we saw earlier, the shape keys. Both of those are things you're going to want to play around with. Expect you to, like, along with tweaking the values if you are following along, I would do that 2 or 3 times. Right. Over here on this grass, we used a blender color, but what if we did that without any movement on the grass? That would look a lot better on that grass material, right? So to do that, let me click on this riverbank real quick, because I'm expecting you to do stuff. So if I choose the mesh for the riverbank, notice we have surface material overrides. So there's the surface material that we brought in from Blender, but there's also we can override it with a new shader. So you could do something similar to what we just did over there with maybe without the movement, and make dark and light patches of grass without affecting your collision body either. And then use mesh instances to put periodic, like tall weeds and stuff and trees and stuff. That should give you a starting point to making a really nice world. Shaders, are what I was wanting to get through today, so you can start playing around with those and just start playing around with those over this weekend. That's my recommendation. Oh, yeah, there's tutorials. Get as far as you can in the tutorial, but again, one of the things, please let me know how much time you work on it and be accurate about it, because I'm going to use that for future planning. Always before, there has never been a measurement taking, so I just went with double the time of the tutorial, but that is not accurate. That's just a random guess. So if you all could go ahead and take measurements, let me know how much time you're working. That's part of the criteria. Instead of finishing the game, I'm going to look at how much time you spend on it. So, but not really, right? If you're completely, it's finals week, so if you're completely overwhelmed, I'm not going to penalize you because you can't find time to work on this, right? This is a hard subject, time consuming. Find as much time as you can, but please let me know how much time you spend. That way, in future classes, when I use YouTube tutorials, I'll have a better idea of the time scale to go with.
How much time you spent versus how far you got in the tutorial.
Yes, and I added a link to a racing game too. If you haven't looked at it since Monday, there's also a racing game now, but that involves a lot more physics, so it might get a little bit complicated to code, but it's there if you want it. Does anybody have any questions about that stuff? So play around with those things, and yeah, if you start playing around with these tools and then don't get to the tutorial at all, send me this stuff for the 3D assignment. Right, but just get practice with it. That's what it takes. Start getting practice. Shape keys and shaders will make huge differences on your world, because a tree would probably be really nice with a shape key, right? Get some wind going, and then move all your trunk stays still and the branches move a little bit with the wind. Different parts of the branches move different amounts with the wind, and a shape key is really, really nice for that. Just a thought. Get some practice with them. If you have any questions, let me know. Otherwise, that'll be it for today, and I will see you all on Monday. I'll give it a few seconds to see if anybody, for those on Zoom, to unmute.
Honestly, with the way this is turning out, I might refine this and use it as the basis for the demo of my actual game.
Nice. Okay, I assume 5 seconds of silence means no questions. If you have any, let me know. I know at least one person said they're going to stick around. Otherwise, I'll see you all on Monday.